Today I'm going to be completing the straight edges that I started roughly a year ago. So if you saw the first video and you're wondering how it all turned out, this is the video you've been waiting for. Hi, I'm Dennis Frechette and welcome back. About a year ago, I started an experiment that involved creating your own straight edges without any kind of a reference surface. There's a theory out there, that involved using three separate pieces of metal and then systematically comparing the edges of those three pieces of metal until all the irregularities canceled out. So the first video explained the theory behind that. I've been doing work on it, and now I am ready to give you the results and give you some further insight as to the actual process. So if you're interested in doing this, I can save you a lot of time if you watch the second half of this video. So that's what I have for you today, and I hope it helps you out. Hi, and welcome back. Today I'm going to describe the process that I'm going to use to turn these three pieces of steel into a set of straight edges. My goal is to be able to start making tools that have more precisely fitting parts like this set of calipers. Now this is a modern dial caliper, of course, with, precisely machined parts, but several hundred years ago the first ancestor of this tool started showing up. And they would have been made in a common blacksmith shop that simply learned how to up their game a little bit in order to be able to produce the closely fitting parts that went into making a pair of calipers like this. So for them to do that, they would have needed to first develop a set of tools that would allow them to map out the surface of the whatever plate they were working on and refine that surface more accurately than you could possibly do by eye. Now, I'm not trying to get into the whole chicken and egg discussion about whether surface plates were invented first or straight edges. I was lucky enough to find a good description about how to make straight edges a long time ago, and I need a set of straight edges, so that's what I'm doing today. The process of making a straight edge without using any kind of a reference surface involves systematically comparing the edges of three separate pieces of metal. And in order to do that, of course, you need to have each piece clearly marked so that you are able to keep track of what you're working with. As you can see, I've cut away the back edge of each plate so it's obvious which edge is the straight edge, and I've also numbered them by drilling a hole right through the plate. So 1, 2, or 3 holes uh, tells you which plate that I'm working with. And the holes are also at one end because you need to be able to keep track of the orientation of each plate as you're working with them. The first step is to choose one of the three plates to use as a reference edge, and in this case I'm going to be using plate that's labeled as A or 1 in the actual samples that I'm using. Next I'm going to be taking plate B and I'm going to fit it as closely as I can to plate A. So that means I'm going to be taking away material from plate B until the edge of plate B follows the contours of plate A as closely as possible. And then I'm going to repeat the same process with plate C. Again, I'm only removing materials from plate C. I'm not touching plate A. It's my reference edge. Now, just to be clear, it doesn't matter how crooked the edge is on plate A. The important thing is to have plate B and plate C match that edge exactly. And don't forget, this is the process that was used to make the world's first straight edges. So until we get these straight edges done, we're actually not going to have any way of evaluating how straight the edge is on plate A. At this point, plates B and C should have exactly the same profile, and because they were compared to plate A, they should also be mirror images of the profile of the edge of plate A. The last step in the process is to compare B and C together. If everything was done right, all of the high spots should line up perfectly with each other. This time, to fit the two plates together, I'm going to try to remove the same amount of material from each plate, working both sides down together to get the best fit that I can. Your aim at this point is to have the surface contact between the two plates be as consistent as possible. For the first couple of passes, the plates may only be touching in 2, maybe 3 spots, so it's pretty easy to keep track of where you need to start working. Here you can see that I'm simply using a light from behind and just looking at where the plates are touching, and I'm just registering that spot with my finger, and then I can take the scraper and start working those areas. When I experimented with this process a few years ago, I removed all the material with a file, and I got pretty good results fairly quickly, but then later I realized that the file was really just acting as a jointer, and I was riding over all of the high spots, and that kind of tipped the balances in my favor. For this set of straight edges, I'm going to be using a scraper to remove all the material from the edges. A scraper only has one point of contact, so it can easily ride along all the irregularities in the edge. So this should give me closer results to what they could have expected, 400 or 500 years ago. I also anticipate that this is really going to extend the amount of time it's going to take to make these straight edges. For those of you who are familiar with my Nuremberg box project, you'll remember that I introduced this tool in the 27th video of that series, and there'll be a link for that in the description. At this point, I'm a little further along in the process, and I'm comparing plate 2 and 3 together. You can see how the high spots are all registering in exactly the same spot. I'm starting to coat the edges with a marker just to be able to have a really clear reference of where I need to work. I'm going to continue comparing these two edges together and removing roughly the same amounts from each piece until I get a wear pattern that's pretty even across both plates. So here's what the two plates look like at the end of this step. I've clamped the two of them together so you can compare the edges. You can see how the pattern is very consistent, but there's still a lot more to go. However, it's a mistake to think that you can correct that problem at this point. Don't forget that you are removing material from two plates, so you're working on two variables, and even though I have a good contact, the likelihood of all of these flat surfaces being straight is very unlikely. So even though it's hard to do, the key to this step is really to do as little as possible. Just knock down the high points as much as you can, but don't build in any problems by trying to do too much. So what I've described to you so far is all of these steps that are involved with comparing the three plates together, but that isn't the whole process. Now that I have the first round done, I need to select another straight edge to use as the reference, and then I start the whole process over again. I try to make the other two plates conform to that reference edge as closely as possible. That gives me two plates that are identical. I flip them towards each other, compare those two, get rid of all the irregularities as much as you can. And then when I've gone through all three plates, I go back to the top and start the whole thing over again. And I keep doing that over and over until I get the results that I want. And what you'll find is that each time you go through the process, the major differences between the plates are going to start getting smaller and smaller until eventually they're just non-existent. So the time that this process is going to take is going to be totally dependent on the level of accuracy that you're after. If you're just after fairly good straight edges that are, usable, you'll get results that you want very quickly. If you want super accurate straight edges, get ready for a long haul. So these are the straight edges as they stand right now, and I'm guessing that I'm probably about halfway through the process. So I'm going to keep working on these to see what level of accuracy I actually can get. So I will be doing a part 2 to this video. That'll be sometime in the future because I'm only going to be working at these a little bit at a time. But when I'm done, I'll report back, and hopefully I'll have more to say about the whole process. What I have here are the finished straight edges. I followed the procedure that I described in the last video, and everything worked out exactly the way it was supposed to. However, the training period that I knew I had to go through lasted a little longer than I was expecting. And by that I mean I had the basic idea of what I needed to do, and that was provided by a couple of paragraphs that I found in an old set of encyclopedias in my high school library. So I was solid on that part of the process, but I really had to figure out a lot of the practical side as I was going along. So that took a little bit longer than I was expecting. But once you get that behind you, the process does follow in a very systematic way, and you can see your progress with each step. And you really will get some good straight edges out of this. I can compare any two of these edges, regardless of the orientation, and I will have full contact along the entire length and across the entire width of the edge. Unfortunately, I don't have the equipment to put a number on how accurate these edges are, but one thing's for sure, they are far more accurate than I need right now. And I know from doing the process that if I had a better layout die and better magnification, I would be able to take this to a whole other level. So I couldn't be happier with the results, especially when you consider that I did the entire process with one tool that I made myself. So what I'd like to do now is go through some of the things that you're going to be seeing when you start scraping down these edges and kind of give you an explanation of why they're happening. The first thing that you have to be aware of, and really you have to keep reminding yourself of this, especially in the early stages, is that you are working with three pieces of metal that have uneven surfaces. They all have highs and lows, and the highs and low areas are in different spots on each plate. In this example, number 1 is the reference edge, so I'm going to be comparing 2 and 3 to that edge. And just so you can see what's going on, I've shaded in where the high spots are on number 1. These areas are not all on the same plane, they're just spots that are higher than everything else around it. The line that I've drawn in next to number 1 is an exaggerated cross-section of how that edge actually looks. Now, when I start fitting plate 2 to plate 1, again, you have to remember that plate 2 is also uneven, and its high and low areas are going to be in different places from plate 1. The shaded areas in number 2 represent what you would typically see when you start rubbing the two edges together. And the same holds true for number 3. It has its own topography, and it's going to fit with plate 1 in its own way. And here I've illustrated a particularly annoying problem, and that is the lower contact point in number 3 isn't a high spot at all. It actually fits in a valley between two high spots on number 1. That's particularly annoying because when you scrape that down, the next time you rub the two edges together, it's going to disappear. And it'll reappear again once you scrape down the high spots next to it, and then it'll disappear and reappear. You know, that was a really hard one to figure out. One of the things I did when I started out, and it really cost me a lot of time, was I felt that I needed to do the same amount of work on plate 2 and 3, and basically I had to work them together. But that isn't the case at all. 2 and 3 in this part of the process are totally separate plates. They both need to be fitted to plate 1, but they don't relate to each other at all at this point. So it's faster to just go ahead and work with plate 2 in this example, and then when you have that fitted the way you want, you go ahead and work with plate 3. What you're aiming for is to have at least 3 good solid reference surfaces on each plate that line up perfectly. Once you have those 3 points established, you can go ahead and start comparing edges 2 and 3 together and start leveling out all of these high spots. And it's really important to get this step right, because the key to this whole process is getting all of those points to line up so you can pair them back evenly and start creating the basis for the straight edge to develop. The main problem that you're going to have when you're working on these straight edges is gauging how much material that you need to remove. Removing too little material really isn't a big problem because all that does is slow your progress. It's just going to take you longer to get where you need to be. On the other hand, removing too much material can really cause some big problems because it'll make a contact area that you've been working on totally disappear because now it's lower than the surrounding areas. So obviously you're going to need to scrape these areas down because they're showing up as a contact surface, and If you take off too much material again, those areas are going to disappear and your original contact surface is going to reappear because now it's high again in comparison to the surrounding areas. So you can be going back and forth quite a while before you realize what's going on. And once again, you have to remember that you haven't really started making straight edges until you've gone through one complete cycle where you're comparing all of the edges with each other. Each time you go through that cycle, you're removing some of the variables. So the first time you go through it, you don't really have anything to work with until that first cycle is completed. Then you're starting to make straight edges, but there's still a lot of areas that you need to work out. So don't be discouraged by the amount of time that it takes to get this process started. Once you've gone through 2 or 3 of these rotations, you're really going to start seeing a lot of changes happening on the edges, and contact areas are going to start to grow or become more numerous, and you're really going to start to see how the whole process pulls together. So the experiment of making your own straight edges was very successful and very accessible for anybody that wants to take the time to do it. Also, the experiment of using a single point tool that I made myself to create the straight edges also worked out really well. However, from this point, I need to make straight edges that I can use out in the shop. So for that, I'm going to be using a belt sander or whatever I need to get most of the way there. And then I'll do the final finishing with a good quality single cut file. For these pieces, I just need to get the job done, so I'm going to use whatever works best for, that application. The 3 green straight edges at the bottom are the 3 edges that I just completed. They will only be used now as reference edges. So that means that if I need to build a new straight edge for the shop, I'll be using one of those to set the edge, and then they will get stored in a box and not used for anything else. The black straight edge that you see at the top is my new shop straight edge. So that'll be created from one of the reference edges that I have, and then that'll go out in the shop, get used, and then I'll take a reference edge every once in a while to make sure that it's still true and it hasn't been damaged from, any knocking around that it's going to take in the shop. I will be cleaning up and repainting the original straight edges just to repair a lot of the wear and tear that they received just from the handling that was required to make them. But from this point on, they're going to have a pretty easy life. So that's the process as it stands right now. I've put in enough hours to feel confident that, there probably won't be too many changes coming along. But if I do come up with anything, I'll definitely post another video to keep you up to date.